Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. So in the previous classes students, I think we have stopped sets at Venn diagrams of sets. Okay, so we'll be continuing from there. So in today's class, we'll be having a look at some properties related to union of sets. So what is union of sets, students? Union of sets is nothing but an operation between two sets where we write the repeating elements only once and the non-repeating elements also we include them in that set. So the properties of union of sets are these union of set is commutative. Okay, this will satisfy the commutative law. The union of sets will also satisfy associative law. Union of sets will also satisfy distributive law. So what is distributive law? It's not included here. So let us write number 6, distributive law. So that is nothing but A union B intersection C. So you can write this as a distributive law. So this is nothing but equal to what, students? A union B intersection A union C. So what does union of sets satisfy? Union of sets satisfy commutative, associative and distributive. Apart from this, it also satisfies the idempotent law. I think we have discussed this in the previous class as well. Idempotent laws, laws of universal. So that is U union A is equal to U, A union A is equal to A, and law of null set also. So A union null is equal to null. All right. So these are the few properties of union of sets. Moving on to the next one. Properties. Okay. Apart from this, there is another thing called as symmetric difference. So what are the symmetric difference? Symmetric difference is represented like this. Okay. So this is A, set B, and this we call it as delta. Okay. This is a Greek symbol again. Triangular in shape. A delta B. So students, here you see A delta B can be written as A minus B union B minus A. What is this called as, students? This is called as symmetric difference between sets. So A minus B means what? From set A, subtract or remove. So this is minus sign, right? Remove all the elements of B. Similarly, from set B, remove all the elements of A. So that is nothing but symmetric difference between two sets. So each one of these properties can be proved by taking some random examples. So here we'll prove one or two properties only. All right. So let us take set A equals 1, 2, 3, 4. All right. And let us take set B equals 3, 4, and 5. So to prove the properties of union of sets, okay, we'll be taking the second one, A union B union C. So that is nothing but equal to A union B, okay, A union bracket B union C. This is associative, okay. So however, the same example you can take and you can prove all the properties. So let us find out the RHS, A union B. So A union B means what? Writing the repeating elements only once and non-repeating elements also you have to include. So what are repeating here, students? 3, 4 and 3, 4 is repeating. So you could write it only once. So that is 1, 2, 3, 4 and 5. So this is A union B. So but set C also we have to consider. So let us take set C here. So set C will be equal to, so this was 3, 4, 5. So let us write 5, 6 and 7. So this is set C. We'll find out what is LHS. Alright. So we'll come on this side. LHS will be equal to A union B union C. Okay, so this will be RHS. LHS will be A union B union C. So what is A union B? We already found out here. 1, 2, 3, 4, 5. Now A union B union C. So that is nothing but 1, 2, 3, 4, 5 union. C will be writing it as 5, 6 and 7. So again we are using which operation here? Union operation we are using. Means what? We have to write the repeating elements only once. So 5 is repeating in both the sets. So therefore LHS will be equal to 1, 2, 3, 4, 5, 6 and 7. So this is our LHS. Okay, we'll also find the RHS, but finally we have to prove LHS is equal to RHS. So RHS, B union C we have here. So let us write B union C. So B union C can be written as 3, 4, 5, 6 and 7. 5 is the repeating element. We are writing it only once. Okay, and A we already have 1, 2, 3, 4. So RHS will take A union B union C. So A is 1, 2, 3, 4 union. B union C is nothing but 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. So A union B union C again can be written as repeating elements should be written only once, 3, 4 and 3, 4. Correct? So 1, 2, 3, 4, 5, 6, 7. This is our RHS. This is our LHS. So what did we prove here? We finally proved LHS is equal to RHS, which means the union between the sets is associative in nature, or the union satisfies, the union operation between the sets satisfies associative law. The same example you can consider A, B and C, and you can try proving the remaining of the properties here. So this all whatever properties are mentioned here, okay, every properties will get satisfied. Symmetric difference also I've explained. So let us take the same example and try out the symmetric difference. So let us take A is equal to 1, 2, 3, 4 and B equals 3, 4, 5. So what is A minus B, students? A minus B. So from A 1, 2, 3, 4 remove all the B elements. So B elements is only 3. So remove 3 and B element is also 4. So remove 4. So A minus B will be equal to 1, 2. B minus A. So from B remove all the A elements. So B has 3, 4. A also has 3, 4. So remove 3 and 4. So B minus A will be equal to 5. So what is the symmetric difference between two sets now? A delta B, this will be equal to 1, 2 union 5. So therefore A delta B will be equal to, the symmetric difference between two sets will be equal to 1, 2 and 5. Understood, students? So this is about properties of union of sets and symmetric difference. So now we have seen union of sets, right? The next what we are going to say is intersection of sets. The intersection of sets also satisfy commutative law, associative law and distributive law. Distributive law whereas, okay, it also satisfies distributive. So that is on the next slide. Properties on intersection of sets. So this satisfies commutative law, this also satisfies associative law, this also satisfies distributive law. Apart from that, it also satisfies idempotent law as we have seen in the previous. So idempotent law in the previous was A union A is equal to A. In intersection, what are we seeing? A intersection A is equal to A. So law of universal and null set is also getting satisfied for intersection of sets. So this is about some properties of the operations on the sets. Moving on to the next. Practical problems on union and intersection of sets. So students, to solve these practical problems on sets, okay, you have to know the Venn diagram very nicely. So here I'll be drawing two Venn diagrams. Okay, one is the standard one. Okay, we'll keep that as reference. Another one we'll take it as an example and solve the problems here. Okay, one small example we'll do before we get into the examples again. Okay, very small. So the reference one I'll be drawing right now. So the reference will be in black in color. Alright, so this we'll keep it for reference. So this is for our reference. Alright, so this is set A, this is set B. And another Venn diagram we'll draw very similar to this. Okay, this will take it as a problem. Okay, same thing. This is set A. Here we'll write A. And this is set B. Here we'll write 1, 2, 3, 4 and 5. In the black one, students, which is the standard Venn diagram, this is for reference. So this is set A again, correct? And this is set B. So here we'll be using different colors now. I'll tell you why. Let this be, okay, we'll take it blue color. This is A minus B. So which is A minus B? See this thing. This entire thing is A minus B. So which is only hatched in blue color, okay, that is A minus B. We'll take another color here. We'll take purple. So this is A intersection B. A intersection B. Okay, A intersection B. So that will hatch in purple color. On this side, we'll take another color. We'll take light blue. Okay, so this is B minus A we'll take. Okay, B minus A. We'll take another color. Just a second. Maroon will take. B minus A. Understood. So from the reference diagram of Venn diagram, okay, from the black color, what can we write? Can we write it like this? A union B. Okay, so this will be equal to what? Blue part, that is A minus B. A minus B plus, we put that in the bracket. The purple part, A intersection B. Plus again the maroon part, B minus A. Correct? So this is what we can derive from this diagram. Now have a look at this. What is this green color, students? See this green circle. Okay, what is that green circle? That green circle is nothing but B. Correct? It is the entire B set. So B can be written as what now? B will be equal to B minus A, okay, which is this maroon part, okay, inside the bracket, plus B minus A is nothing but only B, means we are not considering A elements. So that is only B, plus there is another purple part here, so that is A intersection B. Understood? Going on to the next one, we'll take black color. Okay, now see this part, see the black part. So what is that black circle again, students? Overlapped circles. So that is nothing but A, the entire A set. So the entire A set can be written as what? A minus B, that is nothing but only A minus B plus the common elements between A and B, that is A intersection B. Correct? So this is what we have derived from this Venn diagram. Now we'll come to here. Okay, this is one small example. So I have written few numbers also inside set A as well as in set B. First of all, we'll see what is n of A union B. Okay, now this is referring to this diagram. N of A union B means how many elements are there in A or B. You can count it, students. 1, 2, 3, 4, 5. So the number of elements in A union B, that is nothing but number of elements in A or B, this will be equal to 5. Understood? What is n of A minus B? Number of elements in only A. Only A means you see, only this part. Number of elements. How much? 2. Number of elements in only B, that is this one. N of B minus A, that is equal to 2 again. And the number of elements in A intersection B, that is this part, that is 1 again. N of A intersection B, which is equal to 1. Understood? What we'll do further, now we'll find out A union B, okay, with respect to A, B and A intersection. So A union B, we found it out, 5. So there are few problems on this, practical problems. So to solve these problems, okay, you have to know these things. So this is very important. Okay, this is very clear, I think, from the diagram. So now you see this A union B. Okay, so A union B can be written in terms of this. Okay, so how is that written? We'll see that on this side. So we'll put a line. N of A union B. Okay, now students, see this. N of A union B can be written as A minus B, A intersection B, B minus A. So that is nothing but N of A minus B plus N of A intersection B plus n of b minus a. Correct? See this? A minus b, A intersection b, b minus a. Same thing I have written there. On the right hand side, we'll be doing a very small operation. And what is that operation is? We'll be adding and subtracting A intersection b. I'll tell you why. Okay. So here we'll write plus n of A intersection b minus n of A intersection b. So you can cancel them both, plus and minus. So when you cancel, you'll be remaining only with the black color, which is also correct. Now to solve on the right hand side, see this? A minus b plus A intersection b. Here it is. A minus b plus A intersection b can be written as what? A. Correct? So A minus b plus A intersection b, this one we will write it as what? N of A. How did we write this? From the reference Venn diagram, the relationship what I have written. Similarly, students, see this? B minus A plus A intersection B. So this can be written as what? N of B. How did we write that? Understood. So finally, the final equation of N of A union B, okay, N of A union B can be written as N of A plus, which is this, N of B, that is nothing but this, minus this one, N of A intersection B. So note this down. This is also called as addition law. Okay. So to find out the number of elements in A union B, it is N of A plus N of B minus N of A intersection B. Alright. So keeping this formula or remembering this formula, we'll be solving few examples. Okay, so just make a note of this. Okay, we'll start with few problems. I'll just clear the board. Alright. So the very first problem, students, so this is an example. So whatever we saw until now with reference to Venn diagrams, we'll be using them here. Okay. So in a school, there are 20 teachers who teach mathematics or physics. How do we write that? N of mathematics or physics, M union P is equal to how much? 20. Of these, 12 teach mathematics. So 12 only teach mathematics. So again, N of M. 12 teach mathematics, N of M is equal to 12. 4 teach both physics and mathematics. See the word here, and. So here we can write N of M intersection P. So this will be equal to how much, students? 4. What is the question? How many teach physics? So we have to find out what is N of P. This will be equal to question mark. Understood? So how have we written this data? This data has been written from this question. Now in this question we have to find out what is this quantity. To find out this quantity, what are we going to use? We are going to use whatever we have seen before this. That is nothing but that formula. So what was that formula, students? The formula is like this. N of, we'll take, instead of A and B, we'll take M and P only. Okay. So M union P will be equal to N of M plus N of P minus N of M intersection P. This is the formula we saw. In terms of A and B, now we are changing only the variables M and P. Do you know this? Yes, we know this. So that is nothing but equal to 20 equals N of M we know, that is 12, plus N of P we do not know. Let us write that as it is, N of P. M intersection P do we know? Yes, 4. So these both are numbers again. Operate them. 12 minus 4 is nothing but equal to 8. Send this plus 8 on that side. It will become 20 minus 8. So finally we can write, therefore N of P will be equal to 20 minus 8, that is nothing but equal to 12. So there are 12 teachers who teach physics. So this answer is your right answer. This is very important. Okay, you can treat it as a formula, addition law. Important this is. Okay, remember this part. So this is the first example which we have solved using the Venn diagrams. Okay, so by Venn diagrams also we can solve this. So here we have used addition law. So by using Venn diagram, how to solve the students? So like this, very simple it is. Okay, so let us take it as M. Let us take it as P. Mathematics and physics. So teachers who teach mathematics is 12, right? Both mathematics and physics. So this is both. So here we will write 4. Correct. So always write the common part first. 4 you write. So mathematics is 12, but there is already 4 existing in M. So what can you write here? Here you can write 8. Correct. So totally it is 12, right? 8 plus 4. See this mathematics circle. Totally it is 12. Now total number of teachers are 20. So 8 plus 4 is 12. How much is remaining? 8 plus 4 is 12. 8 more is remaining. So you have to write 8 here. So now here, what is n of m? N of m is 12. What is n of m minus p? N of m minus p is 8. What is n of p? N of p is 12 again. What is n of p minus m? N of p minus 1 is 8 again. What is n of m intersection p? M intersection p is 4 again. So totally if you add this, are you getting 20? Yes. 8 plus 8 is 16. 16 plus 4 is 20. So total number of teachers are 20. So they have written there. So by using Venn diagrams you can solve it. Okay. So but I suggest you to use this type of solution for your MCQs. Okay. But you have to follow this type of solution for your descriptive paper in your boards. So if you write the solution in this way only, you are going to get the marks in your boards. For MCQs, you can go for this method, Venn diagram. Alright, moving on to the next. Practical problems on union and intersection of sets. The next example, students. One example we finished. So there are 200 individuals with a skin disorder, total number of people with skin disorders. 120 has been exposed to chemical C1, 50 to chemical C2. Okay, so what can we write here? N of C1 is equal to 120. N of C2, this will be equal to 50. Okay. And 30 to both chemical C1 and C2. So N of C1 intersection C2, this will be equal to 30. Okay. So find the number of individuals exposed to chemical C1 but not C2. How do we write this? So that is nothing but N of C1 minus C2. C1 minus C2. Chemical C2 but not C1, N of C2 minus C1, C2 minus C1, and C1 or C2, that is nothing but N of C1 union C2. Now students, see this is what you have to find out. N of C1 minus C2, this is very similar to N of A minus B. So what is N of A minus B, students? Okay, we'll go back to the previous slides again. Okay, so just a second. Okay, that has been erased. Fine. No problem. N of C1 minus C2 can be written as what? N of C1 minus C2 can be written as N of C1, correct? N of C1 minus N of C1 intersection C2. So this is nothing but what, students? N of C1 minus C2. Similarly, this one, N of C2 minus C1 can be written as N of C2 minus N of C1 intersection C2. Okay, next one, C1 union C2. So addition law, I think we can, so this also will write is equal to N of C1 plus N of C2 minus N of C1 intersection C2. Alright, so we'll find out the very first one, N of C1 minus C2. Okay, just a second. So N of C1 minus C2. So here we'll write N of C1 minus C2 is equal to N of C1 120 minus N of C1 intersection C2 30. So 120 minus 30 is 90. This answer is correct for the first one. The second one, students, N of C2 minus C1. N of C2 minus C1, this is equal to N of C2 50 minus N of C1 intersection C2 30. So 50 minus 30 is nothing but 20. This answer is also right. The last one, n of C1 plus C2 minus C1 intersection C2. So that is nothing but what is C1 here? 120. C2 is 50. C1 intersection C2 is 30. So that is 170 minus 30. That is nothing but 140. This answer is also right. So these are the practical problems which you can use, okay, which you can solve using sets. So 2 examples we have done. So this is the end of the chapter, students. All right. So we have finished the synopsis of sets with few examples in this. So we'll be stopping the class here. So this is the end of the chapter 1 of class 11 mathematics called as sets. I'll be seeing you